keeping your nose out of it, denying yourself access to production. That's what we're going to talk about today. A little bit about my background, why I'm talking about this. I'm Glenn. I work currently in a small law tech startup in Stavanger on the west coast of Norway. I've been working as a consultant mostly, and I've been consulting in both regulated and unregulated industries. And currently, as I said, working in a law tech startup, we handle people's wills, contracts, all kinds of legal stuff in your personal life. But in essence, it's a whole bunch of personal, very private information. So I have this thing about keeping that information safe and secure. It's the thing that I hold dear to my heart. And also in some industries that are regulated, you actually have to do these things. The trick is to do it in a way that doesn't suck. Because we've all had those stories where you want to get something done and there's a guy with a weird hat and a bag that's preventing you for something. He usually works in security, has this shoulder satchel instead of a backpack or something like that. Oh, odd folks, those. He's often Irish as well, for some reason. So why would you deny yourself access to production? Well, there's a number of reasons why you would do that. First of all, blamability. If you couldn't touch it, nobody can blame you for having touched it. Nobody's going to pull up production interview and tell production, show me on the doll where Carl touched you. Because you couldn't. So in one way, it's a sort of a cover your own ass. Right? If production's broken and you couldn't touch it, it wasn't you that broke it. So we want to prevent negligent or inadvertent user, the developer that's just going to do a small quick fix. We also want to prevent the criminal user, the malicious user who's actively out to do harm. We don't like it, but they exist. They're usually pissed about something, they were often pissed about something that has some kind of grievance, and they want to screw things up, preferably in a way that you won't find it, or find out it was them. Maybe they want to delete some data, maybe they want to change some data because they were mistreated, they were fired at a bad time in their life, whatever. You have the criminals, the ones that do it for fun and money and profit. Because they want access, with access to your customer data or your user data, they can get a benefit of this. And then you have attackers that have somehow compromised your honest, God-fearing developers' machines or accounts and use those accounts as a jumping board. These are not theoretical situations. There's a saying that there are two kinds of developers. Those who have deleted data in production and those who have not done it yet. Anyone here ever delete data in production by accident? Yeah, it's a couple. I appreciate your honesty. My first incident of deleting data in production was we had an online CMS tooling that we created. And it was super easy to use. It was this was in the early 2000s, and they had a rich text editing field in the web browser, which was actually pretty awesome at the time. This seems like a normal thing now, but this was back in the day where rich text editors on the web was not really a thing. Sorry. And the problem with this, well, the good thing about this is it gave our end users a lot of power. The problem was it gave our end users a lot of power. Because they would take documents in Word and copy and paste. And has anyone ever copied HTML from Word? It looks horrible. So they did something and it was completely screwed up, and they asked them, can you fix it? And of course I can. A couple of regexes will solve this problem in no time. So I copied out the HTML, fixed it up, pasted it back into my SQL management tool. Update article, set body text equals, so-and-so, control that. No! I forgot the where clause. So I updated 365 articles with exactly the same body text. Well, luckily we had backups. Unfortunately, we never had restores. So we backed up and made sure the backups went, but we never managed to we never tested the restore process. And if you have a backup process without testing the restore process, you don't have a process, you have hope. So my night was spent. Anyone remember Google? When you Google something, you open cached view? So my night was spent taking every single of those 365 article headings, copying the title, pasting it into Google, cached view, copy what Google had, and then pasting it back into the article. So yeah, that was fun. That's how I learned to use transactions with begin rollback whenever you do something weird in SQL. And also write the select first and then change that to the update. Criminal users. One super simple example is the example that we had in Norway a bunch of years ago where a bank employee was discovered for selling account information to the gossip magazines about celebrities. So it would say how much money the crown princess had in their bank account, for instance, which other people are not supposed to know. But they had access to this because any bank employee could look up any account. There was a recent case in Norway where the welfare administration scandal, where lots and lots of people have been looking into other people's case files without due process. And not even looking into, but also they got a massive fine for the potential of people being able to look into it. Just because it was technically possible, they got fined for that. And of course, attackers, there's almost too many to be named. One of the biggest things that happened in the recent years, anyone hear about the Maersk scandal? Maersk attack, where a malicious download package was downloaded from some tax program in, I think it was Ukraine actually, from a small satellite office, and a little worm started that spread its way throughout the entire network and destroyed. That's actually a really interesting story. So having to deny yourself access to production limits these attack surfaces and accident surfaces, where you have to do some extra steps, even if you want to get access. Personal data might be in your production database. It might be illegal to just have the potential to access it, as has been shown recently in Norway. There was a case recently where with Vercel employee, did you see this one? A person had their site on Vercel, and they got an email from Vercel employees saying, yeah, you need to change your project name because it collides with a personal project I have. That wasn't weird. This is not a general talk about security in your apps, your network. It's a much broader topic for that. But it is about creating those barriers or having those barriers and what we're going to do about those barriers between us and IT and development and our team around us and our production data. So, possible consequences. Loss of trust. That equates into money. Financial losses directly from that. Loss of trade secrets. Compromise of customer data translates into money. Regulatory fines, money. Falling share prices, ruined business reputation. All of this are consequences of inadvertent access to production data. And it usually all comes down to money. You will lose money. The object here is not to make it impossible to get access to production. But there's two things we want. Explicit and auditable. We want it to be an explicit action to access production data. We want it to be something, not something you do by accident or that you have constantly, but it's an explicit step, like I am going to access production data. And we want it to be footpaths in prints in the snow. We want to be able to see who accessed production data, when did they do it, and why did they at least claim to do it. Traditionally, there's been a difference here between smaller and bigger shops. You had the bigger shops with that horrible, horrible word, governance, where you had weird people that would say, no, we have to do it this way because this one consulting company told us that we have to do it that way because we have to fulfill some weird standard that is completely subjective, and they filtered it with their own content, so we're going to follow this rule and nobody really knows why, but we're going to do it. Anyone here change their password every 90 days? Yeah, it's bullshit. You don't have to do it. No single standard ever mandated that. But consulting companies doing security audits for those standards said, well, in order to fulfill this demand, which is actually kind of vague, we're going to say that you do that by changing your password every 90 days. But the actual standard never said that. They said you should have sufficient things in place to prevent so-and-so. And then McKinsey said, well, we'll do that, but change your password every 90 days. Fun fact, now the standards say that that is actually actively harmful. So that's another matter. So we had those bigger shops where nobody had access to production. I had a case where I had to debug an error in production. That consisted of me writing some debug code. We had to do some more logging statements. Taking that file, sending it to a guy in 4 or 5 time zones off, where he would put that into the program and he could compile it, because the developer couldn't compile a production app themselves. That wasn't a thing. So he would compile it. He would ship it to an ops guy in Sweden that would install it on the server. And he'd tell us that it's installed. Okay, we'd go and run the actual thing. And would let him know, okay, we've done the thing, and he would take the logs, export them, and ship them to me in email. It's not exactly the developer inner loop going really fast here, is it? On the other hand, on smaller companies, everybody had access to production. All the time. Process? Nah, we have speed, power. You want in production? X-copy that shit in. Because they didn't have governance. And then you had, of course, there's a spectrum here, but these are the things. And I do believe that in the latest years, we've gone somewhat down, a little bit, the pendulum's gone a little bit too far the other way for the bigger shops. The cloud came, ubiquitous server infrastructure everywhere, self-service. People set up platform teams, and you could just go online in your shop. I would like 4 servers, please. Boom, here's your service, thank you. Like a couple of websites, here's your websites. And of course, here's your little corner of production, and you have full access to that for the development team. We have autonomous teams, and this is all very good. And now everybody has full access to production. Almost every developer with more than 10 years of experience had one of those stories where getting things in production involved black magic and sacrificing chickens and all kinds of stuff. So the self-service cloud and the cross-functional autonomous teams have, in my opinion, greatly increased the number of developers that have access to production on a regular basis. Or push things straight into production without having to talk to ops or security or anything. So we decide to lock ourselves out of production. Great. But we still need to put things in there. A code, for instance, that is to go in there. And so the question is, and also sometimes you really need to get things out of there. You really need to access some information in this production. You have to debug production data. You have to access some logs, some sort of setting. You will need that access. The real question here isn't how do we completely lock us out or how do we not have access. The question is how do we keep our agility? Because it's easy to lock ourselves out of production. That's just hire this one guy that sits over there and everything has to go through that person. But we want to keep the agility. We want to deploy whenever we want. We want to get access to the data when we need it. So we want to keep that agility, keep our access, and keep our data and our systems secure. Now this is part of, but certainly not the whole thing, of a concept called zero trust. Zero trust security concept centered around the belief that you should assume that your system has been breached. The basic assumption is that your system has been breached. That is the absolute reverse of how it used to be. It used to be that if you were on the network and in the domain, you and your system was secure. So before we had systems with a security boundary, as long as you were inside that boundary, you were good. That has proved to be wrong multiple times. So the other thing here is zero trust. We trust no one. Verify always. It's like the sign you have in some bars. In God we trust, everyone else pays cash. So never trust, always verify. No entity, a user, a device, or application is trusted by default. Also, a concept called least privilege access. Least privilege access means that you should have just enough access to do what you want to do. You shouldn't be global administrator because sometimes you need to add an application to your Enter ID setup. You shouldn't be domain admin because sometimes you need to access that folder. You shouldn't have contributor rights to your Azure subscription because you're going to manage this one website. Another concept, of least one of the other tenets of zero trust, which we're not going to touch that much about, is microsegmentation. And also continuous monitoring. We're going to touch a little bit about that. But that means to make small segments of your app or system that say you're going to get access to this part. This other part, not so much. None of your business. So you should definitely look more into zero trust. It is a thing and you should do it, but we're going to keep on with our little show. One thing you should do, first of all, is set up your super user account. You should absolutely have, because it is absolutely possible in today's systems to lock yourself out completely. If you configure things the wrong way, you have irrevocably, on your own at least, locked yourself out of your whole system. This is your ultimate failsafe. This is the account that owns everything. Your individuals in your company should never own the infrastructure. A subscription should never be owned by a person. A resource should never be owned by a developer. They should be owned by some kind of system account. And at the top, owning everything should be your super user account. This account should, as a rule, not be logged into. It is your emergency escape hatch. You start everything with this, and then hopefully you never need to use it again. It should be sufficiently secured. You should probably not use an MFA phone thing for it, because that is, again, connected to a person, and if that person joins the circus, you have a problem. You can use things like these, hardware keys, which you can mandate for this user to log on, you need also to have this hardware key plugged into your computer. Hardware keys can be secured physically in safes. Password of these users can be secured physically in safes. Whatever you do. Audit the crap out of this one. You should get a notification, multiple people should get an email notification if that user ever logs on to anything. If there is a sign-on with this user, people should know. Start there. The next thing you should do, you should start with your code. So we have our code, and we need to get that into some production environment, some bucket that is your production. This should always be automated. We know this is a good rule, we have DevOps processes and so on. So most of you already have some kind of automated deployment. CD, continuous deployment. Continuous deployment, not in the sense that you deploy all the time, but at any point in time you're able to deploy. It can, of course, be a manual approval steps and all that, so you can say we're going to deploy now, and then it happens. The clue here is that you do not deploy. You tell a system to deploy. So we have some kind of service account or service identity that does the deployment for us. For instance, we use GitHub Actions. Our GitHub instance has been given what's called a federated identity in our Azure Entra ID directory. And that federated identity is locked down, saying that this repository and this branch in that repository is allowed to operate as this identity. And this identity has sufficient permissions in this resource group to do deployments. I should not have that permission. My colleagues should not have that permission. But that GitHub repository branch does have that permission. The other branches do not have that permission. So this service account has some kind of keys to the kingdom. So that's your code coming in. We can also put our infrastructure as code. Instead of logging in and doing what's called ClickOps and clicking yourself to whatever portal you're using for your infrastructure, creating servers and doing that, and of course, by that, having lots of access. You define your infrastructure in code, and then again, let the service account do it. You might have multiple service accounts, one for the code, one for the infrastructure. They need two different levels of permissions. Same thing with removing services. You want to remove a service, remove it from the infrastructure code. The process of deploying it will automatically delete it. You can use for this, in Azure, you would use ARM or Bicep. Don't use ARM, that is assembly language for deployments, use Bicep. You can use, what's it called in AWS, CloudFormation, is it? Something. You can use other tools that are higher in the stack, Terraform, Pulumi, that will work across clouds and in lots of different environments, that will set up your infrastructure for you and make it available. Once you have code and infrastructure code automatically being deployed into your environment, you need to make sure that that code is not malicious. that people don't just go in and delete all your servers from infrastructure and code, deploys it, and suddenly your environment is gone. That would be inconvenient. So for your code, you can do pull requests or whatever form of review you want. So Bob makes some code, wants to get it in here, and somewhere along the line, there's a form of review process. You want 4 eyes on that code. The person who makes it and someone else. We do review processes for multiple reasons. We do it because we want to learn, we want to increase the knowledge, share the knowledge of whatever is happening in our system. But one of the major points of it is actually making sure that nobody's doing something stupid. Because people do mistakes. And while all of our employees are presumptively adult people and do good, they want to do their best, sometimes people make mistakes. So require some form of code review, especially going into production. Of course, everyone has different threat models. The seriousness of the code review can be adjusted to your threat model. This is not a cookie cutter, fits every single one perfectly, but this is one step you probably should do if you're keen about protecting your environment. The point is not to prevent someone from pushing code to production. The point is just having another set of eyes looking at the code to making sure nobody's doing anything dumb or some malicious code is not coming into your system. Passwords. They're fun, aren't they? You should never use them. Passwords suck. Passwords are bad for multiple reasons. Because one, it doesn't prove anything except that you know a series of words or have access to a series of letters. It doesn't prove your identity. And passwords, they're like STDs. They can be passed around, and once you have one, it sticks with you. You have it forever. You cannot give someone a password and then just take it away from them. Once they're given that password, they have access to that password, and they have access to everything that the password grants them access to. Passwords floating around is a problem. You do not know who has that password. Whenever someone touches that password, it affects them. They have it. They have access to it. And they have access to whatever the password is. So database connection strings often have passwords in them. That means everyone who can read the database connection string can read all your production data. It's not a good thing. Rely on identities instead. For instance, in Azure, which anyone here use Azure? Yeah, quite a few. You have the concept of managed identities. You can create an identity where you will never have access to the credentials of that identity that is held by Azure, and you can assign that identity to a service. And saying you will operate as this identity. And then you can grant that identity access to resources. You can grant the identity access to your database. You can grant it access to storage, to other services. The other part you can do is use certificates, which are harder to keep around or pass around, which services can use to create or instantiate an identity. These certificates are easier to lock down than a password. There are services that can create a certificate and never expose the private key. And you can grant someone access to go in there and use that key, that certificate, to perform actions with it. These can be installed in services, various things. You can, if you're using infrastructure and code, automatically create secrets, install them in vaults, and there are numerous products on the market for this. Azure Key Vault is one if we're using Azure, which I'm partial to. And you can grant access to these secrets and say, hey, only this identity over here has access to read this secret. I do not have access to read it, but that service has access to read it. So as much as you can, get rid of the password use identities. The passwords are secrets you have to do. Put them in a vault. Keep it secret, keep it safe. Secrets is not configuration. Many people keep secrets along with configuration. Saying, oh, here's your logging settings, here's the address for the email server, and here's the password for the email server. That is not a configuration part, that's a secret. These two things are completely different and should be handled completely differently. They can be integrated. For instance, we use a service called AppConfig, which has all the different settings and key value pairs. But one of these settings, or a setting can also be a pointer to some kind of vault, specifically Azure Key Vault. Secret. So the configuration isn't the secret, it's the name and location of the secret. So here's the configuration settings, here's your logging settings, here's your email server address, and here is where you find the email server password. And then the service will get that, and then it will, oh, okay, I'll need to go over here, and it will present its identity to log on to the vault and say, I would like to have access to this, I would like this secret, please. Oh, here you go. Thank you. And you're off. Another advantage of using certificates over regular secrets is that they expire. And that they usually can be rotated. Where you can set up a certificate. This is also often the key. This is often the case with some keys that can be rotated, where you have key pairs. You have two keys for a service, or you can have published multiple certificates that you accept, and then you rotate these on a schedule suiting your threat model. You can rotate them multiple times a day if you want. And the way you rotate secrets or keys or certificates is that you use one, but accept the old one for a period of time. And then you phase out the old one, you introduce a new one, you start using that, but you accept the old one for a period of time. And this continues. One of the things we regularly need access to from our production environment is logs. So one of the things you can do is take these logs and push them outside of production. Of course, you have to take care of your logs that you don't log information that should not be read outside of production. This is where the code review comes in. But looking at logs is for many a daily activity. A colleague of mine, he starts his day by looking at logs for the night. What's going on? Do we have anything weird going on here? Any anomalies? Any errors that we should look at and take care of? No system is flawless. There are always errors and edge cases we didn't think about. Especially if you have user input. They input a lot of weird stuff. Of course, he Here as well, you grant access to some individuals, and you do not grant access to some other individuals. Not everybody in the entire company needs to be able to read the logs. Some people do, some people don't. Least privilege access. But allows you very often to see what's going on and start troubleshooting without having to compromise security in the same way. Back to configuration. Configuration should also be separated from your application instance. That means you can change things, change the way your application behaves without having to redeploy, without opening that security hole of pushing code in. Depending on the solution you use, you can often change the configuration, have that application automatically update these things. For instance, we're going to increase logging for a short period of time. We're going to log more. Or we're going to enable this one feature and see how that works. And we can do this without having access to production because we can say, okay, the configuration instance can also be outside the regular production environment, depending on what you have in configuration. Of course, then configuration shouldn't be able to enable destruction or compromise of your production environment. But again, we can have that and allow access to that without having to give access to all of it. So the biggest threats is, in my mind, is people having continuous access instead of just having access to what they need. The access is too broad. That can easily be solved with stop giving people too much access. That is an easy fix in any organization. And the use of passwords. Passwords floating around. And of course, many of these things are convenience things. Because you're not set up to easily handle the edge cases when you absolutely need access to production. And in some organizations, that happens a lot more than people would like, but it does happen, and it's useful, and it's needful. So what do we do when we have a production environment and we absolutely need to get access? I need to access this one piece of information in here. Well, one way of doing it slightly, so remember back when I started, the idea here is not to make it impossible, is to make it explicit and auditable. So there's multiple ways. One, I can use a VPN to access, which is a common thing that a lot of organizations do. It says, yes, you can access production, but you can't access it directly from your machine. We have blocked your machine from accessing production. Not necessarily you, but your machine or your network cannot do it. So in order to get in, you have to use this VPN solution to create a tunnel between your machine and the production network. It's not very zero trusty, because it's saying once you're in the VPN, then you have permissions. So you have the same idea of you're within the fence, you just made the fence smaller and you put a gate in it. A variant of VPNs are bastion service or jump service. That you log on to a server that is like halfway in, halfway out. So you log on to this, and then this has access. It's just a variant of the VPN, just in my mind, slightly less convenient. But we established both those things of making it explicit. You're taking an explicit action. I'm going to VPN into production. I'm going to log on to the jump server. And in some cases, you have to VPN in and then log into the jump server. And then you get the other step as well, auditable. We can audit the VPN. We can audit logins on the jump server. So we created these things. These things are sometimes not as convenient to set up because you don't have a VPN infrastructure. The VPN is set up with a username and password. And you have VPN with a common username and password, which sort of defeats the purpose of making it auditable. Another variety is to use some kind of just-in-time system. Just-in-time permissions is a system where you can go in and say, hey, I would like to have this permission. I would like to be able to do this thing. And the system goes, sure. How long do you want to do it? I'm going to need that access for about 2 hours. Excellent. Why do you want to do it? I want to do it because so-and-so. You'd put in a little reason. Great. Here you go. Or, great. I just need to ask these people first. So these are systems that will allow you to get some kind of permission assigned to your account for a defined period of time. When that time is up, the permission is automatically removed. You usually have to put in some kind of reason. Why do you want to do this? And you can enforce an approval process saying that for this to happen, these people should authorize that request. Or you can make it automatically authorized, but you still have the audit trail of it. It steps in the snow. We know that at this point in time, Carl went in and asked for access to production database. The reason stated was dot. Sounds pretty nefarious. And 50 minutes after he did that, our customer table was gone. Weird. Or you can go in and say, well, Carl had access to production, and he had access because he needed to troubleshoot this and this ticket. And you can go look at the ticket numbering and say, oh, so-and-so. And these systems have varied degrees of fanciness. In Azure, this is called PIM, Privileged Identity Management. It is, they changed all the names now, but it's an add-on, it's part of an add-on package if you have P1 or P2 of Entra ID. That's called some governance, something, but ask your local Azure dealer pusher for that. But PIM, Privileged Identity Management, we use it for accessing. Not only we have it for accessing production database, we also have it to be able to perform certain tasks in one of our case handling applications, which is only available to a select few, but sometimes developer needs to do it as well to troubleshoot, and so they can ask for that permission. What PIM does is that it will allow you to create what's called in PIM terms eligibility. They're going to say, you are eligible for this group membership. And your eligibility has a time period that lasts from now till forever, or now for the next year, and then it has to be reapproved, and so on and so forth. And when you're eligible for a group membership, you can go and ask for a group membership and say, hey, I would like to have access to the production database readers group. Excellent. And we can set up an eligibility with approval process or whatever. We can also assign not only group memberships, but also Azure roles or Microsoft 365 roles. So you can add roles or group memberships to you. And that's a great thing because then we have Less blamability because we don't have access to production data at a regular basis. We don't have the trouble of having Azure Data Studio or Data Manager up, and you type some commands in, and you think you're deleting your test data, but that window had a connection to production database. Ask me how I know that is possible. You can also, with PIM, require MFA approval steps, saying that in order for you to activate this eligibility, you have to re-authenticate with a multi-factor authentication. So we're going to need you to prove your identity with some multi-factor. Then you can also specify how long should they be able to ask for. I think there's a maximum here of, I think it's 24 hours, something like that. Or how little should they be able to ask for. And they go in and say, I need this, and I need it for so many hours. Also, a very underrated activity is to make specialized scripts or tools for doing things that you do on a semi-regular basis. It is the old IT rule of 3. You do it, and you do it uniquely the first time. The second time, you think about how you can do this in a general way. And the third time, you generalize the process. There's also the rule, if you do it 3 times, there's a tradition. It is relatively simple to set up a script that can be run by GitHub Actions, for instance. So if you have a thing that you keep wanting to do at a semi-regular interval or on demand every now and again, you can create that as a script, put it into code, and create a GitHub action that says, hey, run this script. And we're already established that the GitHub action can run as an identity in your system. It is relatively easy to set up stuff like an Azure Logic app that can run as a managed identity, have its own access to your system, and you can create steps there that says, okay, you're going to do this thing, and this thing, this thing. We have a web app that is, the designers were not part of making it, let's put it that way, but it contains a bunch of scripts that are super useful for us developers. Instead of, every now and again, something didn't happen that should have happened. Something happened and it fired off an event and it should have done this other thing, but this other thing didn't happen because there was an edge case where the data was ruined and things didn't work. There's 2 ways of fixing this. We can either go and into the production data and tweak the production data to make it the way we want it to be, or we can go into our tool and say, fire off this event, replay it. Which is a simple tool one of my colleagues made like in an afternoon. Just takes the string of an event, here's the payload, play it. And these events are whitelisted, they're non-destructive. Then there's an audit trail to it. If you need auditing in your system, once you make these tools, you also open up for a whole bunch of people to do things. Now you can always audit this. And you can make your own systems audit information, which is great. So we have this log, and we put stuff into it, and we know everything that happened. But the people who have now access sometimes also have access to the audit log. So they can just go, oh, this thing never happened. Oh, and this thing never happened either. So what do? Well, you make an immutable ledger where every log entry contains a little piece of information from the previous. or hash, where if you erase one, the log is broken, which is suspicious. Immutable ledgers, they're also called blockchains, but it has a bad rap, so I prefer using the word immutable ledger. But it has nothing to do with Bitcoin, except Bitcoin also uses an immutable ledger under the hood. There's a feature in SQL Server, Microsoft SQL Server, and also others, that can implement an immutable ledger for you. That does all the work for you that you do not have control over. So you made this wall of separation between you and whatever goes into the ledger and the way that the ledger guarantees that nothing has been changed. And in that immutable ledger, you can't really go in and change the data. It's not possible to do it. And even if it were, it would show up that it had been changed. So nobody can go and change the data and rebuild it. They have to erase everything from now and back to the point of time when they wanted to erase it. So that's a feature in SQL Server. You can create immutable ledgers. So, summing it up. You want the escape hatch, the super user. Keep that there, keep it away, never use it again. You use identities in your system, assign them permission, following the principle of least privilege. They should have just enough to do what they have to do and nothing else. You yourself should have no permissions on a daily basis into production. You are not to be trusted, because we are but human. If you have secrets or passwords, there are ways to store them and keep them secret and only allow access to the identities that actually need them. SQL Server is SQL connection strings are a thing. SQL Server in Azure, for instance, perfectly accepts identities and give them permission from Enter ID. You don't need username and password in your connection string. You can say, we will log on with our Enter ID identity instead. And you can create a external user from external provider user in Azure SQL, and you can give that external user permissions in your database. So that service don't have access to your data because it has a password, and it has access to data because it is who they say they are. If you need access to production, there are ways to do it. Some are worse and some are better than others. I personally prefer the just-in-time variety, where a person can act as themselves and say, I need access to this now for a short period of time. Granted, explicit, auditable, and whatever I do on my own name. I don't do it because I have a password or because I logged on to some other machine or something like that. And also the fail-safe, instead of every now and again jumping into production, doing stuff, just make a tool for it. It will do it the same way, less chance of error, and you can implement it in an audible fashion. Any questions? Everything's clear as day. Yes, sir.
Very small one. Wouldn't you suggest, even if using JIT, to separate it into read and write?
Oh yeah. Oh yeah, we do. I wasn't clear on that. We have, we can JIT, we can ask to be member of, for us, the database production reader group, and database production writer group. And even those groups have limited access. There's not all tables that should be available to that group. So you can narrow down when you're using JIT. Again, the principle of least privilege still applies. You don't JIT yourself into the global administrators group. You have groups and roles for specific tasks. I need to go and do this thing. Great, have access to that. We have our user database is separate from another database, and you can JIT your way into separate ones of these. You can get access to, for instance, the data our customer inputs. That could be one thing. The financial information of payments and stuff like that, that could be another thing. So you make whatever you need to do or whatever makes sense within your threat model, you make those groups. And you make them, again, the least privilege principle applies to all of these things. Yes?
In small team, the person who wants to configure all that is a weak point. If this person who can configure the JIT account, the eligibility.
Yep. That is what you use the super user for. So that's why you have the super user, because you can break the glass, use that to set up the basics, and then once that is done, you use those basics to do the rest of the work. So you can set up the super user to allow you to define eligibility for the role that allows you to set up PIM. And for PIM, it's usually, if, for instance, the owner of groups can set up PIM for their own group. So if you have this permission or you own that group, you can do these things. But you can also have the super user do it. So then you can get you can be assigned owner to a group for a short period of time, and then you can set up eligibility for that group for others, and then after a while you lose it. And while the fact that you ask for it, that is now audited. Again, the point isn't to lock one out. The point is to make these things explicit and auditable. Because this stuff needs to get done. We want it done in a secure and safe manner. Reduce the risk of inadvertent errors, reduce the risk of malicious attacks, and reduce the risk of malicious attacks from the outside, of compromise. So by having, for instance, high-powered groups should always have approval. That reduces the risk for malicious attacks from the inside. And by not having the permanent permission, reduces both the inadvertent risk and the compromise risk. Yes, other questions? One in the back there?
According to the CICD, you're supposed to have development branches that are very short-lived. And it's popular to combine that with squash commits. How do you feel about squash commits in terms of how you
So you should have development branches that are short-lived, and you should have squash commits. Is that what you're saying?
if you have squash commits, like how
Yeah.
do you feel about squash commits?
So what we do is that we have a development branch, or staging branch, and we have a main branch, and main goes in production. So we do reviews against staging, and those are always squashed. And then we do a merge from staging to main. So in main, we have a complete history of all the things that went into main. But in the feature branch, which are also always deleted after use, we just squash all of that in, because they are usually very short-lived, and all the little mini commits don't really convey interesting information. So that's the way we solve that problem. Other questions? Oh, yes, over there. Sorry.
I can just add to that. Usually if it's in Azure DevOps, you have the link to the original commits. So you can go there. They're not exactly the part of the squash commit, but they can replicate the exact history.
Yeah, you still have the commits. The commits are there even though the branch is gone. So you can see all the code that went in. So we can see the original PRs that went into staging, and you can see the make another PR from staging and gather a few of the ones into main. So these are all saying, good point. Other questions, concerns, comments? Yes?
What's the name of Immutable Ledger in SQL Server?
What's the name of the feature? Have you Googled SQL Server Immutable Ledger?
Not yet.
That's what I do. I never remember all these names. Server, immutable table. I think they just call it ledger, by the way. Yeah, ledger.
Thank you.
Yeah, ledger. It came to SQL Server 2022. And also Azure SQL and Azure SQL Managed Instance. I'm sure other databases have similar things. Probably if not, you have specialized immutable ledger software that will do the same thing for you. More questions? We're out of time, so I hope you enjoyed NDC so far and have a great weekend. Oh, since we're some of the late courses, they've asked me to help, if you can ask them for some help with cleaning up. So if you could just do your share and take the green cards and put in that box over there, that'd be incredibly helpful. Thank you.